Today we're going to work on diagnosing this 2010 Toyota Camry with inoperative air conditioning. Now the customer said it is working okay, it's in the hot Texas heat, but eventually over time it got a little bit less cool. And so it got finally to the point where the customer would eventually get all the way home from work before the car started cooling off, and that's not good, especially on a day when it's 110 degrees outside. Not real comfortable. So first thing we need to do is hook up our gauges and verify the charge level. Now this thing, we're in about an 80-degree shop, and we've got roughly 100 psi shown on the high and low sides here of our gauges. We've got enough freon that this compressor should be engaging. Except there's one little variable here. This is a electronic variable displacement style compressor. So we've got the system turned on to max AC, all the way cold. We've got the fan on high, and I'm actually using my temp select tool here as well to illustrate for you all. You can see we've got the red probe connected to ambient temperature, hooked in the grill. We've got the blue probe inside the vehicle in the duct, and we can see that it's actually, well, it's actually warmer inside the vehicle. So while we've got freon in there, the compressor appears to be turning, but it's not cooling the cabin of the vehicle here. So what do we need to do? Well, first thing we need to do is actually detect if the PCM is sending a command signal to the control solenoid on the compressor. Well, how do we do that? We can look through scan data, see if there's any circuit codes. There wasn't on this particular vehicle, but scan data on this car does not show us the PCM command of that solenoid on the AC compressor. So that's where we use a special tool now, and I'm actually going to take this tool. It's got a lot of different electrical connectors here, so I've already gone ahead and got the specific connectors here, and I'm going to now plug my tool in series with that compressor, and this is going to allow me to monitor the electrical circuit. It's also going to allow me to monitor the PCM command of the control solenoid. Now in some different vehicles it might be the body control module, the HVAC control module. We're going to be able to monitor the command signal to it and see what's going on, and then we're going to also be able to manually control this ourselves, ramp that compressor up, and see if it has any type of effect on our pressures here. So I'm going to shut the car off, plug this in series with the compressor, and then we'll take a look. All right, so I've got the tool plugged in here. I've burned my arm on the exhaust manifold, so be careful, it's hot and we have to get near that exhaust. So I've got the tool powered up, and before I start the vehicle again, I'm going to simply hit the check resistance button here and check, and it shows me I've got 10.9 ohms resistance on the circuit. And that's really normal. That's what I would expect to see on that control solenoid. So that tells me that it's not open circuit for some strange reason. Next step is we're going to go start the vehicle, and I'm going to watch the control module's command of that solenoid. All right, so now that I got the vehicle on, I've got the AC commanded max control here. If you look, you can see that the control module is commanding that compressor to 95.3%. It's trying to drive that thing max pressure. And we should see some change on our gauges here. However, it's still showing static pressure. At this point, it's really a slam dunk. It's time to replace that AC compressor now. So now with the tool, we've been able to verify it's got the correct signal going to it. It's just not responding to the command. If we weren't seeing this type of signal here, now I could go into manual mode and really ramp up or ramp down the compressor to see if there was any corresponding changes on my gauges here. But we've already verified that the control module is making the request. The compressor is just not up to the task here. So once again, it's time to replace this compressor here. Hopefully now this gives you a little better understanding of part of the diagnostic process with a variable displacement compressor, and how this particular tool is a real lifesaver when it comes to making the decision. Is it a command issue or is it actually a compressor issue? Thanks for tuning in. Check back to our channel to look for additional helpful tips similar to this one.